Hi everyone, Mr. Lee here. In this video, we're going to do Atwood machines, but with multiple objects. So far, we've done Atwood machines, but with only one or two hanging objects, but I'm going to show you how to do it with multiple ones. So this can be for 3 objects, 4, 5, 6, 7, 8, 9, 10, however amount of objects is necessary to complete the problem. Okay, so a couple of things. Remember, the string on this Atwood machine that connects M1 to M2, that's just one giant long piece of string. However, we have a new string right here connecting M2 to M3. That string is not a part of the giant string up here. And that's because M2 doesn't have a hole through it. Okay, M2 is just a solid object. Alright, now that I have my drawing, the next thing that I'm going to do is a free body diagram. So I'm going to do M1 first. So for M1, I have a force of gravity going down. I'm going to call this FG1, and we have the tension right there. We have tension along that string. I'm going to call this T1. Now you might notice that before I just called it T for tension, but because there's multiple strings, we have to be a little bit careful. Alright, so there's no other piece of string, or excuse me, there's no other forces there, so we're good. Let's go to M2. So for M2, we have the tension that is coming from the rope, and the tension is pulling on M2 upwards. Okay, now because this is the same string and the tension along the string is always continuous, so it's always the same, I'm going to call that T1. Okay, it is the same rope that is connecting M1, right? And M2 also has a weight component. We're going to call that FG2. All right, and the next one I am going to do is M3. Oh, excuse me, let's go back to M2. You'll notice that M2 also has a secondary string right there. Okay, so what this rope is doing is this rope is pulling on M2 downwards. So I'm going to call that T2. I'm going to zoom in on this so I can have an easier time showing this. Yeah, so this rope that's connecting M2 to M3, that also has a rope. Okay, so that rope is called T2. We're not calling it T1 because it's a separate rope. All right, now for the last one, let's do M3. So we're going to start off with the rope that's connecting M2 to M3. We're going to call that T2 because it's the same rope. Okay, and we have the force of gravity going down. So we'll call that FG3. All right, so here is my free body diagram. So this is good and all, but what we really want to do is we want to swing out the axes. And so, let me get this stable. To swing out the axes, remember we want everything to move along the same axes. I'm going to call that axis X. Okay, we want everything to be along that axis. So I'm going to swing this object upwards like so. I'm going to swing both of these objects up like so. Okay, so I'm going to use this as a reference as I create the the adjusted Atwood machine. So I'm going to start off with the little wheel right there. Okay, on the left hand side I have the rope, and connecting to the rope I have M1. So this is M1. All right, now before T1 was facing straight up, but when I swung it out like this, T1 is now pointing to the right. All right, FG1 was pointing downwards, so when I swing it out, FG1 is now pointing to the left. Then we have the rope that continues, and the first thing that it hits is M2. Okay, so if we take a look at M2, we see that T1 is pointing up, but when we swing out the object, this upward facing tension now faces to the left. We're going to call that T1. And we have FG2 that's pointing downwards, but when we swing it out, okay, that downward force will now point to the right. And this rope right there, T2, let me include the rope right there. I made it a little bit bigger so I have more space. That T2 will be also pointing to the right. All right, and now we can do M3. M3, we have this tension, and it's pointing, it's kind of hard to see, it's going to be a little bit bigger. That tension should be pointing upwards, and so here, I'm going to make tension point like so, because when we swing it out, the upward force will now point to the left, and this downward force there, when we swing it out, it'll point to the right. Okay, so that's probably the hardest part about doing these Atwood machine problems, is readjusting the axes into something that we want. Okay, so now what we want to do is we want to create a net force equation. Okay, the net force, and we're all in the x-axis, but just as a good habit, I'm going to write that down. We have F equals ma. Okay, so the first thing that we want to do is we want to add up all the x forces. Now remember, anything to the left is negative and anything to the right is positive. So we're going to start off here. We have negative Fg1, positive T1, negative T1, positive Fg2, positive T2, negative T2. That negative T2 is from the one connected to M3, and of course positive Fg3 to finish it off. Okay, so I should have 1, 2, 3, 4, 5, 6, 7 forces. 1, 2, 3, 4, 5, 6, 7 forces. All right, we're good. All right, and it's equal to, remember, this is the system's mass, and so the system has M1 plus M2 plus M3 times the acceleration. Okay, so technically this is the final equation that we need. But we can clean it up because we can see that T1 minus T1, that cancels out, T2 minus T2 cancels out. So what we're left with is negative Fg1 plus Fg2 plus Fg3 is equal to M1 plus M2 plus M3 a sub x. Right? Okay, so that's how you do a Atwood machine for multiple objects. All right, so let's say, we're adding a new trick here. Let's say we want to find the tension. Okay, we want to find the tension for, let's say, T1. Now, usually when we want to find the tension, we just go to our net force equation and we just solve for tension. But we can't do that because tension is canceled out here. Right? We see that tension is canceled out. So my trick in order to find the tension is to not look at the Atwood machine as a whole, but rather focus in on just one of the objects. So you know what? I'm going to highlight this. I'm going to focus on M1 only. Okay, so this is the trick. We're focusing on M1 only. So I'm going to redraw that because that's looking a little bit messy. So to find tension, okay, to find tension. So I am going to draw my free body diagram for M1. So we have T1 there and Fg1 right there. All right. Now, before, when we create our net force equation, all the tensions cancel. But when we focus on just one of the objects, let's see what happens here. Okay, so we have the forces is equal to mass times acceleration. Okay, and we have T1 minus Fg1 is equal to mass times acceleration. Okay, so if we take a look here, we see that T1 isn't being canceled out. So we can rearrange this so that T1 is equal to ma plus Fg2. So we found the equation to find T1. Now, here's my warning. When you are doing this with numbers, be very careful. So usually for a problem, we have the mass, okay, M1, and we know that Fg2 is just mass times, mass 1, mass times the acceleration due to gravity, and we have the acceleration due to gravity, we have mass 1. And so the only thing that you're missing usually is the acceleration in order to find the tension. Okay, we need to find the acceleration. And we found out how to find the acceleration up here, right? We would just find the acceleration and we would know what all the other variables represent. But we got to be careful. Okay, because this acceleration is in reference to this acceleration right there. Let me do this in black. This acceleration right here is in reference to this drawing. Okay, so when you do the math and the acceleration, according to this drawing, if it were to come out as a positive value, that means the side with M2 and M3 is moving to the right. Okay, positive means it's moving to the right. So that means that according to this image, if we have a positive acceleration, the Atwood machine is being pulled downward. M2 and M3 is going down. Okay. However, if we have an acceleration, after we do the math here, and the acceleration comes out negative, that means that, excuse me, I should also write M1 here. Okay. M1, M2, and M3, this entire thing is shifting to the right. However, if our acceleration is negative, that means M1, M2, and M3, right, all of that is accelerating to the left, okay, because the leftward direction is negative. So that means that M1 had a greater mass, it had a greater weight compared to M2 and M3. So that will be the situation. So if your value is negative here, that means according to this drawing, this the M1 portion, this part will head down and M2 and M3 will rise up. Okay, compared to if we have a positive acceleration, M2 and M3 will fall down and M1 will go up. Okay, so keep that in mind when you use this equation. All right, you got to be very careful with what your acceleration value will be. So if you were to have a positive acceleration here, okay, that means that this object is accelerating upwards, and according to this image, upwards is positive. And for here, if you have a acceleration that's negative, that means that this object will be sliding down, like so. Okay, all right. So that's how you do Atwood machines with multiple objects. In the next video, we're going to do modified Atwood machines with multiple objects. I will see you then. Bye-bye.